track lighting wiring must be derated to 80% of its ampacity. This derating is required due to the increased heat generated by the track lighting fixtures. The derating requirement applies to all track lighting installations regardless of whether they are commercial, industrial, or residential. Track lighting fixtures typically have multiple lights on a single circuit, which can draw a significant amount of current. Derating the wiring helps to prevent overheating and potential fire hazards. The derating factor is 100% for all other types of lighting loads. The derating requirement does not apply to the branch circuit conductors supplying the track lighting transformer. To further understand the requirements, let's delve deeper into the National Electrical Code Section 210.19 A3. This section specifically addresses the allowable ampacity of branch circuit conductors. It mandates that the conductors must have an ampacity sufficient for the load they serve. The load calculation should adhere to Section 220 of the Code, ensuring that all demands are accurately accounted for. Now, when applying these requirements to track lighting, it is essential to consider the unique characteristics of this type of lighting system. Track lighting systems often consist of multiple lighting fixtures connected along a single track, all powered by a single branch circuit. This configuration allows for a high concentration of lighting within a relatively small area, leading to potentially significant current draw. Because of the concentrated nature of track lighting and the potential for high current draw, the National Electrical Code requires that the branch circuit conductors supplying track lighting be derated. This means that the allowable ampacity of the conductors must be reduced to 80% of their normal ampacity rating. The purpose of this derating requirement is to mitigate the risk of overheating and potential fire hazards. By derating the conductors, the amount of current they can safely carry is reduced, preventing them from exceeding their temperature rating and potentially causing damage to the insulation or surrounding materials. It is crucial to note that this derating requirement applies to all track lighting installations, regardless of whether they are in residential, commercial, or industrial settings. The National Electrical Code does not differentiate based on occupancy type, as the underlying principle of electrical safety remains the same. Furthermore, it is important to understand that the derating requirement does not apply to the branch circuit conductors supplying the track lighting transformer. If the track lighting system utilizes a transformer to step down the voltage, the conductors supplying the transformer are not subject to the 80% derating factor. However, the conductors on the secondary side of the transformer, which supply the track lighting fixtures themselves, must still be derated in accordance with Section 210.19 A3 of the National Electrical Code. In addition to the derating requirement, it is also essential to ensure that the track lighting system is properly installed and maintained. This includes verifying that all connections are tight and secure, that the track is properly grounded, and that the lighting fixtures are compatible with the track and the branch circuit. Regular inspections and maintenance can help to identify and address any potential issues before they become a safety hazard. When selecting conductors for track lighting circuits, it is crucial to consider the ampacity rating of the conductors, as well as their insulation type and temperature rating. The ampacity rating should be sufficient to handle the derated current draw of the track lighting system, while the insulation type and temperature rating should be appropriate for the environmental conditions in which the conductors will be installed. In some cases, it may be necessary to use larger conductors than would otherwise be required in order to meet the derating requirements and ensure the safe operation of the track lighting system. It is also important to consult with a qualified electrical contractor or engineer to ensure that the track lighting system is properly designed and installed in accordance with all applicable codes and regulations. They can provide valuable guidance on conductor selection, circuit sizing, and other critical aspects of the installation. Moreover, it is worth noting that the National Electrical Code is not the only standard that may apply to track lighting installations. Other standards, such as those promulgated by underwriters' laboratories, may also contain requirements related to the safety and performance of track lighting systems. It is important to be familiar with all applicable standards and to ensure that the track lighting system complies with all relevant requirements. Finally, it is essential to emphasize that electrical work can be dangerous and should only be performed by qualified individuals who have the necessary training and experience. Working with electricity can result in serious injury or death if proper safety precautions are not taken. If you are not comfortable performing electrical work yourself, it is always best to hire a qualified electrical contractor to do the job for you. In summary, the derating requirement for track lighting wiring is a critical safety measure designed to prevent overheating and potential fire hazards. By derating the conductors to 80% of their normal ampacity rating, the risk of exceeding their temperature rating is reduced, ensuring the safe and reliable operation of the track lighting system. This requirement applies to all track lighting installations, regardless of occupancy type, and should be carefully considered when designing and installing track lighting systems. Always consult with a qualified electrical contractor or engineer to ensure that the installation complies with all applicable codes and regulations. In addition to the derating requirements outlined in NEC 210.19 A3, there are other considerations for track lighting installations. Firstly, you must ensure that the track lighting system is listed and labeled by a recognized testing laboratory, such as underwriters' laboratories. This listing indicates that the system has been evaluated for safety and performance and meets the applicable standards. Secondly, the track lighting system must be installed in accordance with the manufacturer's instructions. These instructions provide detailed guidance on the proper installation and operation of the system, including information on mounting, wiring, and maintenance. Thirdly, the track lighting system must be properly grounded. Grounding provides a path for fault current to flow back to the source, helping to protect against electrical shock hazards. The grounding conductor must be properly sized and connected to the track and the electrical system. Fourthly, the track lighting system must not be overloaded. Overloading can cause the system to overheat and potentially lead to a fire. The total load in the track lighting system must not exceed the ampacity rating of the branch circuit supplying it. Fifthly, the track lighting system must be protected by an overcurrent protective device, such as a circuit breaker or fuse. The overcurrent protective device must be properly sized to protect the branch circuit and the track lighting system from overloads and short circuits. Sixthly, the track lighting system must be installed in a dry location. Moisture can damage the electrical components of the system and create a shock hazard. If the track lighting system is to be installed in a damp or wet location, it must be specifically designed for that environment. Seventhly, the track lighting system must be accessible for maintenance and repair. This means that the system must be located in a place where it can be easily reached without having to remove or disassemble other parts of the building. Eighthly, the track lighting system must be installed in a neat and workmanlike manner. This means that the wiring must be properly supported and secured, and that all connections must be tight and clean. Ninthly, the track lighting system must be inspected regularly for signs of damage or wear. Any damaged or worn components must be replaced immediately. Tenthly, it is important to be aware of any local codes or regulations that may apply to track lighting installations. These codes or regulations may impose additional requirements beyond those outlined in the National Electrical Code. By following these guidelines, you can help to ensure that your track lighting installation is safe, reliable, and compliant with all applicable codes and regulations. Remember to consult with a qualified electrical contractor or engineer if you have any questions or concerns about your track lighting installation. Let's explore the application of these principles through an example. Imagine a retail store is planning to install a track lighting system to highlight merchandise. The track lighting system will consist of several fixtures, each drawing a certain amount of current. The total calculated load for the track lighting system is 16 amps. According to NEC 210.19 A3, the branch circuit conductors supplying the track lighting must be derated to 80% of their ampacity. To determine the minimum required ampacity of the conductors before derating, we divide the total load by the derating factor 16 amps/0.80 equals 20 amps. This means that the conductors must have an ampacity of at least 20 amps before derating. Next, we need to select the appropriate size conductor to meet this ampacity requirement. According to NEC table 310.16, which provides the allowable ampacities of insulated conductors, a 12 AWG copper conductor with type THHN insulation has an ampacity of 20 amps at a temperature rating of 90 degrees Celsius. However, we must also consider the termination temperature limitations of the equipment to which the conductors will be connected. If the equipment is only rated for 75 degrees Celsius terminations, we must use the 75 degrees Celsius ampacity rating of the conductor, which is 20 amps for 12 AWG copper with type THHN insulation. In this case, a 12 AWG copper conductor with type THHN insulation would be sufficient to meet the ampacity requirement for the track lighting system, even after derating. However, it is always a good practice to consult with a qualified electrical contractor or engineer to ensure that the conductor size is appropriate for the specific application and to verify that it complies with all applicable codes and regulations. They can also take into account factors such as voltage drop, conduit fill, and ambient temperature, which can affect the ampacity of the conductors. In addition to conductor sizing, it is also important to consider the type of overcurrent protective device to use for the track lighting circuit. The overcurrent protective device, such as a circuit breaker or fuse, must be properly sized to protect the branch circuit and the track lighting system from overloads and short circuits. The size of the overcurrent protective device should not exceed the ampacity of the conductors. In this example, since the conductors are 12 AWG copper with an ampacity of 20 amps, the overcurrent protective device should not exceed 20 amps. A 20 amp circuit breaker or fuse would be appropriate for this application. It is important to note that the overcurrent protective device must be of the correct type for the application. For example, a circuit breaker should be used for circuits that are likely to experience frequent overloads or short circuits, while a fuse may be more appropriate for circuits that are not likely to experience these types of events. Always consult with a qualified electrical contractor or engineer to ensure that the overcurrent protective device is properly selected and installed. Furthermore, it is crucial to ensure that all connections in the track lighting circuit are tight and secure. Loose connections can create heat and lead to a fire. All connections should be made using approved connectors and should be tightened to the manufacturer's specifications. Regular inspections of the connections should be performed to ensure that they remain tight and secure. If any loose connections are found, they should be tightened immediately. Moreover, the track lighting system should be properly grounded to protect against electrical shock hazards. The grounding conductor should be properly sized and connected to the track and the electrical system. The grounding conductor should also be connected to a grounding electrode system, such as a ground rod or a water pipe. Always consult with a qualified electrical contractor or engineer to ensure that the grounding system is properly installed and maintained. In addition to the technical aspects of track lighting installations, it is also important to consider the aesthetic aspects. Track lighting can be used to create a variety of different lighting effects, such as accent lighting, task lighting, and ambient lighting. The type of lighting effect that is desired will depend on the specific application. For example, accent lighting may be used to highlight artwork or other decorative objects, while task lighting may be used to provide illumination for specific tasks such as reading or cooking. Ambient lighting can be used to create a general level of illumination in a room. When selecting track lighting fixtures, it is important to consider the type of light bulb that will be used. Different types of light bulbs produce different colors of light. For example, incandescent light bulbs produce a warm, yellowish light, while LED light bulbs can produce a variety of different colors of light. The color of light that is desired will depend on the specific application. It is also important to consider the energy efficiency of the light bulbs. LED light bulbs are much more energy efficient than incandescent light bulbs, so they will save energy and money over the long term. The placement of the track lighting fixtures is also important. The fixtures should be placed in a way that will provide the desired lighting effect without creating glare or shadows. It is also important to consider the height of the ceiling when placing the fixtures. If the ceiling is too low, the fixtures may create glare. If the ceiling is too high, the fixtures may not provide enough light. Track lighting can be a versatile and effective way to light a space. However, it is important to consider all of the factors discussed above to ensure that the installation is safe, reliable, and aesthetically pleasing. In conclusion, the National Electrical Code Section 210.19 A3 mandates the derating of track lighting wiring to 80% of its ampacity to mitigate overheating and fire hazards. This regulation applies universally across residential, commercial, and industrial settings. Adherence to this code, along with proper installation practices and regular maintenance, ensures the safety and efficiency of track lighting systems. Electrical work should only be undertaken by qualified professionals to minimize risks and guarantee compliance with all applicable codes and regulations. Additionally, considerations such as proper grounding, secure connections, and appropriate selection of overcurrent protection devices are crucial for a safe and reliable track lighting installation. Furthermore, the aesthetic aspects of track lighting, including fixture placement and bulb selection, should be carefully considered to achieve the desired lighting effects while maintaining safety and energy efficiency. Remember that consulting with a qualified electrical contractor or engineer is essential for ensuring that your track lighting system is installed correctly and complies with all relevant standards and codes.